Hello everyone, Namaste from India. My name is Piyush and I welcome you all in this new video. So in this video, we will be building our own load balancer, and please note that this is a part of Mr. John Crickett Coding Challenges, and we will be building this load balancer in JavaScript and Node.js. So without any further delay, let us move on to our topic of discussion. So the first question arises in your mind is, what is a load balancer? So load balancer is used to distribute the loads among different servers. They can be any number of servers. So rather than relying on a particular one singular server, we will distribute our load onto the multiple servers so that the load is being evenly distributed in the peak times. So let us move on to the documentation. I will attach this link of this particular challenge in the description box. So please check it out. So I would request you all to read this. And now we will quickly move on to the step 0. I have written my own personal documentation for your ease. So first step is install the dependencies. And please note that we will be using Node.js and the dependencies will be Express, request module and Nodemon. So we will quickly install it up here. So the first step is npm init. We will initialize a package.json file. Okay, and the next thing will be we will install all the dependencies. So first is Express, next is Nodemon, so that we don't have to manually restart the server, and the third is request module. We will install them all. Okay, so meanwhile it is getting installed, I will create a load balancer file which will be our main load balancer.js file. Load balancer.js. Okay, so the dependencies are being installed. We will quickly initialize Express app. Okay, and now we will create an app which will load the Express module, and also we will instantiate the request module. Okay, and now we will start our server, that is load balancer, on let's say port number 5000, and we will log a message as load balancer running on port 5000. Okay, now we will quickly test whether it is working or not. So I will use Nodemon, or you can simply use node load balancer.js. So here it is saying load balancer running on port 5000. But if you have installed the Nodemon library, then I would request you all to use Nodemon load balancer.js so that you don't have to explicitly restart the server again and again. So our load balancer has been running on port 5000. So we have created a basic server, which will be a load balancer serving on port 5000. Step 1 has been completed. Step 2 is create backend servers, which will act as the backend endpoints, which will be serving on port 8080, 8081, and 8082. So the step will be pretty similar. So I will create a 8080.js file, 8081.js, and the third one will be 8082.js file. So I will simply copy this code from here. I will paste it here, and I will change the port from 5000 to 8080. And here it will be 8081. And similarly, okay, I have to copy it all. Here it will be 8082. Okay, so we have set up the backend servers. Also, we will use a particular endpoint that will be a normal hash. Let me use a get endpoint, and it will be a hash function. Hash, and this will return us the response as status 200 dot JSON, and it will consist of a message, and that message will be server. Okay, we will be serving from server at port. This will be 8080. So this is our get method. I will do the same for all the remaining 8081 and 8082, and this will be 8081 and this will be 8082. Okay, everything's fine. Perfect. Okay, so the job is done from these files. Now we will focus on our load balancer. Now let's move on to the next step. We have also created the backend servers which will serve on port 8080 and this one. Now the next step is to create a middleware which will send request using a tunnel pipe and also make server index. Okay, so now the next step is, as you know, that this load balancer will be coming first and then it will redirect the traffic onto the other remaining servers. So this particular load balancer will have a middleware because uh, rather than serving from this one particular load balancer, we will serve the content from the sub backend servers. So we will use a middleware here, app.use, and it will be a request response. Okay, so we will first create an object of our backend servers, which will consist of a host and the another flag will be easily flag. So I will create pscmd servers is equals to, it will be an array, in that it will be an object, and here I will specify the host, and first will be 8080, and it will consist of is healthy flag. By default it will be set to true, and we will do the same for other servers also. Okay, so we have initialized our backend servers, and another thing is we want a server index so that we will know which particular server is been serving the request. So as you can notice here, this will be the zeroth, this will be the first index, and this will be the second index. So I will create current server index. By default, it will be set to 0. Okay, so now our step has been completed. And now we have to create a middleware which will send request using a tunnel pipe. And also we have to implement round robin algorithm to find and store the active servers. So you can implement any of the algorithms which will be provided by the load balancer. But mostly in this particular coding challenge, it is mentioned that you should use a round robin algorithm. See, in this step, your goal is to distribute the incoming request between the two servers using a basic scheduling algorithm, round robin. So I would request you to all to get a hint about how round robin algorithm works. So what we will do here is we will create a active server array so that there can be a chance that is healthy will be false, or let's suppose for this 8082 is healthy is false. So there's no point of view in sending the request to this particular endpoint. So rather than that, we will only store the servers which have is healthy as true in this particular active servers array. So we will use backend servers dot for each method, and it will give us a particular singular server, and from that we will push into our active servers array the server. Okay, active servers dot push server has been done. Okay, so here we have to add one condition. Basically, if we didn't specify this particular condition, then it will push all the servers into this active server. So we have to specify a condition which will be if server DOS dot is healthy is equals to true, then only add the server into this active servers array. Okay, so this one has been done. Now the next step will be we will use the current server where current server is equals to, now we have our particular current server index which is set to 0. So what we will do is we will have active servers and current server. So after we have loaded all the active is in the servers into this active servers array, we will fetch the current server index server from these active servers. So we have stored it in current server. Now the next step will be, so as we have loaded our current server, we will now generate a pipe. The reason for generating a pipe is, as you can check here, we are sending the request to individual backend servers. It can be first zero, then first, and then second. So we have to send it in a pipe, in a tunnel, so that we will send a request in a pipe and then receive the same response from that particular backend server in the same tunnel. So here we will generate a pipe and we will use the request model here. In that we will specify the host. The host will be this particular URL. And with that, we have to also send the endpoints. Like after the 8080 port number hash, after that, all the endpoints will be sent in this by using the request.url. Okay, request.url. And now we have sent the request in a pipe. And now the task is to receive the response in that particular pipe, same pipe. So I will use the pipe here and here I will give response. So we will be receiving that in the current server. So after this has been done, so let's suppose we have sent the particular request on this 8080 and we have also received the response. Now the next step is to increment the current server index count to this 8081, or it can be anything. So to achieve that particular thing, I will give comment here. Move on to the next server and we will use current server index and we will simply increment it by 1. But this is not the particular good option, because if we incremented it by 1, then it can be anything. Let's suppose we have backend servers around 10. So it can gradually increase up to 20 or anything. So to find the actual backend server to serve the request, we have to use a modulo operations and we have to pass the total active servers. Please note, not the total backend servers. We want the total active servers length, active servers dot length. So what will happen is, in our case, let's suppose the active servers length is 3 and the current server index now has been moved from 0 to 1. So 1 mod 3, it will be 1 only. So in that case, all the requests will be served as per the particular current server index. So this has been done. Now it's time to check whether our particular round robin algorithm and the middleware has been working fine or not. Okay, so let me start the server from here. Node balancer.js. Okay, it's working fine. And I will change its name to, let's say, LB. And here it will be port number 8080. Here it will be port number 8081. And here it will be port number as 8082. So in 8080, we will start the particular server. Similarly for 8081 and the same for 8082. Okay, the servers has been started in the backend. Now I will move on to the 5000 port number, localhost 5000, and it is saying that server is not defined. Okay, so let us check whether it is the issue. Server is been not defined. 2326 server dot host. Okay, here it needs to be current server. Okay, so we are getting the message serving from server at port 8080. So if I go on this 8080 file, okay, so here we are getting the response as serving from server at port 8080. If I again refresh it, then it will be 8081. And if I again refresh it, then it will be 8082. So this is how our load balancer has been working by using the round robin algorithm. I again refresh it, then it will be redirected to 8080, then 8081, 8082, like that. Now, the case arises if our particular one server fails, that means it is shut it down. So I will shut this 8082 server down. So currently this 8080 and 8081 is been working. So let us check what we get. We are now getting 8080, 8081. Okay, there must be some issue. Let me handle it out. Okay, the issue is by default it is healthy as true, and we have shut it down the 8082 port number server. So that's the conflict which is happening out here. It is healthy as true, and we have shut it down the server. So to handle that, we have the step number 3 to do the health check, and we will handle this particular conflict in this step number 3. So let us move on to that. Okay, so to handle that particular conflict, we will do the health check using interval of 5 seconds. And then we will modify the backend servers for the health check API with using this particular endpoint slash health. And we will send request to that API within 5 seconds. So let us focus on the first task, which is health check using interval of 5 seconds. So for our case, we will use the set interval of 5 seconds. So I will use the set interval module, and it will work for a 5000 milliseconds. That means 5 seconds. So what we have to do is we have to get the particular individual server from these backend servers and check whether it's is healthy or not. So I will simply apply a loop by using for each, and it will have a server in it, and I will create a method health check, and it will I will pass the particular server object in that it will be a host and is alias true. So let us now create a else function. We'll check. It will receive the server as a parameter. Okay. And now how to do the health check? So we will create an endpoint for every backend server, and that endpoint will be app.get slash health request response, and it will simply return us a status code. We don't want any message in this. We only want a status code of 200. That means okay. And we will do the similar for 8081 and 8082 also. So for 8081, for 8082. Okay. So now we have set up the endpoint, and now we will simply send a request to that endpoint by using our request module. Request, and in that we will pass server.host. So this will be passed, and we have to also specify the URL, sorry, endpoint, that will be an help. It will receive a callback function. And now what we will do is, if we don't have any error, and also the response dot status code is equals to 200, that means it's healthy. So what we will do is, for that particular server, we will mark the is healthy flag as true. And with that, I will simply log a message. Let's say server dot host is healthy. Okay. But if it responded, if the server has been shut down, let's suppose 882 is shut down, so it will not give any response for this slash health endpoint. So in that case, it will move on to the else block. And here what we will do is, we will simply mark the server dot easily as false. And here I will mark it as unhealthy. So this health check function has been done, I guess. And this set interval will send this. Okay, so let us try it out and we will cross verify. Okay, so this is also correct. Backend servers dot for each. We have specified the condition for is ls true, then only we will push it up and we will get the current index and we will store the current server here, and we will create a pipe. In that we will pass the request, and after this all has been done, we will simply move on to the next one. Okay, let us try. Fingers crossed. Moving on, load Node.js. 8080 is running, 8081. Okay, we have to restart this also because we added an endpoint here. 88, 80. Okay, what happened here is response to status code is not a function. Okay, let me figure it out quickly. Response dot status code. Okay, I got the problem where it was. So here we are giving response to status code, but we don't want status code. We want to send the status as a response. So I'm sorry for that. Okay, now let us check it again. Okay, load balancer running. Okay, this is also running. Um, okay, so all the backend servers have been running, and let us now start our load balancer. Okay, so it's also started. So the 5 seconds timer is also been running. See here you can notice 8081 is healthy, 8080 is healthy, and it is being sending the heartbeats signals every 5 seconds. So now we will test it out here. So first it is coming from 8080, then 881, then 882, again 8080, 81, 82. So now what we will do is we will stop this 8082 server and let us check what does load balancer show us. So here you can notice 8082 is unhealthy and the rest all the two 0 and 1 is healthy. 8081, 8080, 8081. I will then again stop this 8080 server also. So now currently 0 is unhealthy, 2 is unhealthy, only 1 is healthy. So only 1 is started. So 1, only 1 will be started. No other backend server will work. Now I will start this 8082 again. Let us check here what it shows. So 0 is unhealthy, rest 1 and 2 are healthy. Let us check it out. 1 and 2 are working. Okay, so our load balancer has been working completely fine. So let me again give you a quick recap of what we have done in this code, and we will run this soon. So first step was to create our own server, which is load balancer. And then we created out different backend servers in that we specified and slash endpoint, it can be anything. And it will send us the response as serving from server at port 8080. And also we added a particular health endpoint, which will only send us the status as 200, which will demonstrate whether the particular backend server is running or not. So I will go on load balancer again. So this was our first step. The next step was to create a middleware. In that middleware, we only want the active servers, which has the easily as true. So we looped onto the backend servers and we found out which servers have the ESLT as true, and we pushed it simply into these active servers. So after this was done, the next task was to get the current server, which will execute the request. So for that, we had the current server index, which was initially set it to 0. And from these active servers, we got the index. So let's suppose we have 0th index. So the 0th server will be loaded in this current server. And we now generated a pipe, basically a tunnel, in which we send the request, which was the current server dot host with the endpoint. And we also got the same response in that similar pipe, same pipe. After this service was done, or request and response was done, then we have to move on to the next server so that a particular server does not get overloaded. So to move on to the next server, we used a simple business logic of incrementing the current server index by 1, and we have to make a modulo of the active servers dot length so that which we will have the particular node server without any further conflict. And after that, the next task was to implement the health function, because the problem was that here we have specified is healthy as true, but if we shut it down any particular server, then it was resulting out in an error. So we had the health function here, and we have a set interval in that we were looping on to the backend servers, and for every particular server, we were passing it as an argument in this health check, and here we are receiving it as a parameter. And for this, we specified a request module, which will be sending the request, and it will be sending, let's suppose, on server.host, and the endpoint was slash health. So it will go on this particular endpoint, it will send the status, and we will be checking if it is not an error and status code is 200, then we will allocate it as true. And if it is not, then we will allocate the flag as false. So after this health check is been done, we efficiently use the load balancer. So that was all in this coding challenge. If there are any mistakes done by me or any improvements, so please suggest me in the comment box below. So that was all in this video. This is Piyush Tale signing off. Thank you very much. See you in the next coding challenge soon. Bye bye.